Welcome to solverfy.
In this question, we're given that AD and BE are perpendicular bisectors of each other. And so we're going to use that information to prove that triangle ACB is congruent to triangle DCE. Now, let's start by writing our statements and reasons. So my first statement is that AD and BE are perpendicular bisectors of each other. Now, how do we know this? We know this because it has been given. Next, we want to indicate that they are perpendicular. Let me just put the right angles here. So this is 90 degrees, and therefore this is also 90 degrees. This is 90 degrees and 90 degrees. Yeah. And how do we know that these angles are 90 degrees? So angles at C are right. The reason for this is that two perpendicular lines form 4 right angles. Okay, so that's the next thing. After that, we know that if they are bisectors, AC would be congruent to CD and CE would be congruent to CB. So that's the sentence I should write. That AC, segment AC, is congruent to segment CD, and segment EC is congruent to segment BC. How do I know that? It's because of the definition of a perpendicular bisector. Definition of a bisector, just bisector. Even if I don't write the perpendicular bisector, we know what does a bisector do? It cuts a segment into two congruent parts. So that's given. And then I can say angle ACB, oh, we used the right color, angle ACB is congruent to angle ACD. And the reason is that all right angles are congruent. That's the reason. All right angles are congruent. Now, finally, I can make my statement, my last and final statement, that these two triangles are congruent. Now, I've just shown that these two angles are congruent, and I had already shown that these segments or the sides that include those angles are also congruent. So we see that triangle ACB is congruent to triangle DCE. And what's the reason? The reason is SAS. How does that, okay, how do we arrive at that? It's because there's a side, an included angle, and a side. And also we have a side, included angle, and side. And they are both congruent pairs.